Hey there, this is Akshay Gole and welcome to our video on numerical on simple harmonic motion. So the question is, a simple harmonic oscillator has an amplitude A and time period T. The time required to travel from x is equal to A to x is equal to A by 2 is, and the options are given below. So what we have? We have an oscillator with amplitude A and time period T. The amplitude tells us how far the oscillator moves away from its equilibrium position, while the time period tells us how long it takes for one complete cycle of motion. Since our oscillator starts from extreme position, we can write the equation of motion as x is equal to plus minus a cos of omega t, where omega is the angular frequency of the motion. Now, when x is equal to a by 2, we can put that into our equation to get a by 2 is equal to a into cos of omega t. Now let us solve for omega t. So we'll get cos of omega t is equal to half. What does it mean? It means that omega t must be equal to pi by 3, as omega is nothing but 2 pi upon capital T, where capital T is the time period. So let's put the value. So 2 pi upon capital T into T is equal to pi by 3. So let us solve it and we'll get the value of small t, that is time, is equal to capital T by 6. I hope this video was helpful in understanding and how to calculate the travel time in a simple harmonic motion. If you have any doubt or suggestion, feel free to write in the comment section given below.